Hi, this is Megan and Gabby, and today we're going to be talking about epithelial and connective tissues. First, we're going to talk about epithelial tissue. Epithelial tissue lines body surfaces and cavities. They have closely packed cells that have small spaces in between, except for cell junctions.
They have different polarities between their apical and basal surfaces. They're completely avascular, but they're also innervated. They rely completely on nutrients from the tissues below them.
There's two ways to classify the types of cells for epithelial tissue: simple versus stratified. Simple epithelial tissue has only one layer of cells,
And stratified epithelium has 2 or more layers of cells.
Another way that epithelial cells can be classified is by their shape. Squamous is flat and irregularly shaped, while cuboidal cells have the same length and width, with their nucleus in the center of the cell.
Columnar epithelial cells are longer than their width, and their nucleus sits near the basal surface of the cell.
Next, we will show you some different types of epithelial tissue. First, there's simple squamous epithelium. You can find them in the lungs and the lining of blood vessels. It's important to know that their function is gas exchange by diffusion.
Next is stratified squamous epithelium keratinized. You can identify it by its multiple layers of dead cells at the surface. It's located in the skin, the epidermis specifically. Its functions include waterproofing cells. It blocks diffusion of nutrients as well as waste.
There is also another stratified squamous epithelium that's non-keratinized. This has multiple layers of cells. Cells towards the surface are flattened and become more cuboidal near the bottom of the tissue. However, non-keratinized does not have a dead layer of cells like keratinized does. You can find it lining wet surfaces like the lining of the mouth and the esophagus. Their function is to protection from abrasion and infection.
Next is simple cuboidal epithelium. It can be identified as a single layer of cube-like cells with large round nuclei. It is usually arranged in a circle. Its location includes kidney tubules, thyroid follicles, as well as the salivary glands. Its functions are absorption, transportation, and protection from abrasion.
Next is simple columnar epithelium. You can identify this by a single layer of tall, column-like cells with a single neat row of oval nuclei, usually toward the base of the cell. You can find this in the jejunum of the small intestine. Its function is absorption and secretion.
We also have pseudostratified ciliated columnar epithelium. These appear as if they are multiple layers of cells, but they're actually one layer of columnar cells. They also have cilia on the apical surface that look like tiny hairs. Their location can be in the lining of the trachea as well as the upper respiratory tract. The cilia and mucus secretions help collect foreign materials.
Last but not least, we have transitional epithelium. It's many layers of cells of varying and often irregular shapes. You can find them in their ureters and the urinary bladder. The function of these is the ability to stretch and recoil and to provide elasticity.
We also have connective tissue. These tissues maintain the form of the body and organs, as well as provide cohesion and internal support.
Most connective tissues have an extracellular matrix with a variety of support cells. Some of these connective tissues also have protein fibers. Bone tissue is a connective tissue that provides protection and calcium storage. When looking at bone tissue on a slide under a microscope, you will notice the large black dots, which are Haversian canals. The Haversian canals give the bones blood supply. The smaller dark dots are supporting cells called osteocytes.
Loose areolar connective tissue allows for support, strength, and elasticity. It binds skin to the muscles below, and it also links organs. Under a microscope, you can see dark strands, which are elastic fibers, and light strands, which are collagen fibers. You can also see small dots, which are fibroblast nuclei suspended in a matrix.
Adipose connective tissue, also known as body fat, cushions, insulates, and stores energy. You can find it in the subcutaneous layer that's deep to the skin, in yellow bone marrow, and surrounding the heart. On a microscope, you can see a large white circle, which is an adipocyte containing a fat droplet. On the border of the adipocyte, you can see the nucleus of the cell.
Fibrocartilage provides support and rigidity to surrounding structures. It makes up intervertebral discs, menisci, and the pubic symphysis. The stringy appearance under a microscope is the collagen fibers. You will also see round structures, which are chondrocytes. Chondrocytes produce the matrix that fibrocartilage is suspended in.
Hyaline cartilage provides smooth surfaces for movement and flexibility. You can find it on the heads of long bones, in the larynx and the trachea. Hyaline cartilage also has chondrocytes, which are easy to identify on a microscope slide. They will be suspended in the matrix that they produced.
Elastic cartilage defines and maintains shape. It also supports surrounding structures. It can be found in the epiglottis, the auricle of the ear, and the nose. It looks similar to hyaline cartilage under a microscope. However, the chondrocytes in elastic cartilage are much closer together. Elastic cartilage also has elastic fibers, however, they are difficult to see on a slide.